Howdy folks. What we're going to talk about in this lesson is a subject in economics called elasticity. Now, when I say elasticity, maybe you're thinking of something like a rubber band, and that is good. A rubber band is a good example of what we're going to talk about here in microeconomics. So you could also think about let's say the elastic waistband in a pair of underwear. Okay, or you could think about things that are not elastic, because that's also important when we talk about elasticity. So, for example, you could think about a pair of jeans that you own that do not have an elastic waistband, and so that way the waist on the jeans that doesn't give very much, right? But the underwear, you can stretch it out and it'll come back in, stretch it out and it'll come back in. So this is the subject of elasticity. Now, the idea of elasticity basically says that there are variables in economics that are more responsive and other variables that are less responsive when there's a change going on in a market. And so when we're talking about something that's very, very responsive, very sensitive to change, let's say that. When something is very sensitive to change, we call it elastic. And when something is not very sensitive to change, we call it inelastic. And there's four main kinds of elasticity that we're going to discuss. We're going to discuss one of them in today's lesson, and then in the next lesson, we're going to discuss the other three. And this is what they're called. The first one we're going to discuss today is called price elasticity of demand. And sometimes I will abbreviate it PED, price elasticity of demand. The second one that we're going to talk about in the next lesson is called income elasticity of demand. And so you can abbreviate that IED, but be very careful when you do that and who you say it around, because IED is also an acronym for improvised explosive device, so be careful about how you use the phrase IED. And then the third one is cross elasticity of demand. And so we can abbreviate that CED. Oops, put a C in there. CED, cross elasticity of demand. And then the last one that we're going to discuss is called price elasticity of supply. And so we are going to abbreviate that PES, price elasticity of supply. So what you're going to see is I'm going to describe price elasticity of demand, and then I'm going to describe income elasticity of demand. And by the time I get to cross elasticity of demand, you're going to see a theme in the definition or the description. Price elasticity of demand is how responsive or how sensitive quantity demanded is to a change in price. And so when quantity demanded is very sensitive to a change in price, we call that elastic. But if quantity demanded is not very sensitive to a change in price, we call that inelastic. Now let me give you an example of each one. Let's think of gasoline. Gasoline is an excellent example when talking about price elasticity of demand. People put gasoline in their car. They use them for their lawn equipment. They use gasoline for work. They use it for fun. If they have an ATV and they're out hunting or something, or just having fun driving around. So gasoline is used because people need it and simply because they want it and they want to have fun with it. Now, let's say that the price of gasoline is $2.50 a gallon, okay? $2.50 a gallon. If the price goes up, if the price increases to $2.80 a gallon, okay, so we now have an increase in price. According to the law of demand, there should be a decrease in quantity demanded when the price goes up. And there probably will be a decrease in quantity demanded when the price of gasoline goes up. But will it be a large decrease in quantity demanded? Will a whole bunch of people say, oh my goodness, the price went up to $2.80, I'm not buying any more gas? No, we need gasoline to put in our cars so we can drive to work, assuming we drive, gasoline vehicles. So because for gasoline, an increase in price does not really result in a lot of change in quantity demanded, we would say that gasoline has inelastic demand. It doesn't change very much. It's not very responsive to a change in price. On the other hand, let's think about downloaded music. A song, what does a song cost? Maybe $1.29 to download. So let's say that that each song costs $1.29 to download, and the price of downloading a song goes up to $1.49. And then when that happens, let's say that people who like to download a lot of music, they still download music because they still want to listen to music, but they might say, well, man, I usually download like 20 songs a week, but now I really can only afford to download about maybe 13 or 14 songs a week. They might exhibit, and I'm making this up, I don't know for sure, but they might significantly decrease the number of songs that they're going to download because of the increase in price. And if quantity demanded is very sensitive, there's a lot of change in quantity demanded when there is an increase in price, we would say that demand is elastic. Okay? Now, it can happen the very same way with a decrease. If the price decreases, the price of gasoline decreases from $2.80 a gallon down to $2.50 a gallon. I remember there was a big decrease in gasoline prices it was like 8 or 9 months ago. I didn't buy any more gas. I bought the same amount of gas that I would have. I just pulled up. I drove the normal amount that I would drive. I pulled up to the gas station. I saw that it cost less. I was like, wow, I'm going to pay less money. I put the little pump handle in, and I put in the exact same amount of gas that I would have put in, even if it was a higher price. So gasoline, even on a decrease in price, is probably going to be very inelastic. But let's say that the price of downloading a song went from $1.29 down to what it used to be when I started downloading music, which was 99 cents a song. Man, it went down by 99 cents. I don't really download much music because I think that this is too expensive. When I was young, well, maybe it's, I'm going to be honest with you, it's probably not too expensive. But for me, it's too expensive. But if it was only $1 a song, I'd probably download more music. Maybe not for a lot of other people. Again, maybe this is just for me, but we would then say, so if there's a huge increase in the quantity demanded because there was a decrease in price, then we would say that the demand for that product is elastic. So it's the same thing. If quantity demanded changes a lot when incomes change, so if consumers' incomes go up and quantity demanded changes significantly, we would say that it is elastic. But if incomes change and quantity demanded doesn't change very much, then we would say that is inelastic. So income elasticity of demand is the sensitivity of quantity demanded to changes in consumers' incomes. Cross elasticity of demand is the sensitivity of quantity demand to changes in the prices of other products. And we'll talk about that in the next lesson. And then price elasticity of supply is the sensitivity in quantity supplied to a change in price. And so what we're going to do right now is we are going to focus just on price elasticity of demand. All right, so let's say that we have a product and that this is the demand curve for that product. So look, this is a market graph, okay, except that we don't have a supply curve in here. We're not going to put a supply curve in today. We're just going to look at the demand curve, but we have price on the vertical axis. We have quantity on the horizontal axis. And so what you can see here is this is just a regular old demand curve with some prices, and as the price increases, the quantity demanded decreases, and as the price decreases, the quantity demanded increases. Okay? And so very simply, at a price of $7, demanders, they want only 20 of them. But as the price goes down by $1. Now they want 30 of them. At a price of $5, they'll go up by 10, 40. And basically what's happening is as the price changes, the quantity demanded changes by 10. So this demand curve has a slope of -10. Now that's an important concept. I'm not going to focus much on it, but it's important to understand there might be a point at which you are going to want to think of price elasticity of demand as having something to do with the slope of the demand curve. And in a way, it kind of does, but it doesn't directly have anything to do with the slope of the demand curve. Because what we're going to find here is this, notice, I just want to remind you that this demand curve has a constant slope. This is a linear demand curve in this particular case. It is a constant slope of -10. So remember that if you ever get to the point where you think that it has something to do with slope. And what I want to do now, though, is it's a lot easier to understand, in my opinion, or calculate price elasticity of demand if we have it in a table instead of a graph. But I just want you to see the graph so that you can understand that the table that you're about to see reflects a demand curve. Okay? And so the table is going to have prices in one column and quantities in the next column. All right, so here is the same demand curve, only now we have it in a table. And so at a price of $7, demanders are interested in purchasing 20 units. At a price of $6, demanders want 30 units, and so on. Now, let me explain the calculation, because what we're actually going to do is one of the main parts of this lesson is I'm going to teach you how to calculate the value of price elasticity of demand. There's a formula for it, okay? And the idea in the formula goes like this, that price elasticity of demand is equal to the percentage change. Now I'm using the Greek letter delta here, and that represents the word change, okay? So percentage change in quantity demanded divided by the percentage change in the price of the product. Now, I want to show you one way, it's not the only way, but there are a few ways. I'm going to show you one way that you can calculate the percentage change in a number. Now, if you want to know the percentage change in a value, one way to calculate that is to take the new value and subtract away the old value and divide that by the average of the new and the old. The average value of new and old. Okay? So, just as an example, if I have a number, let's say I have the number 16, and it changes, whatever this is representing, it could be age, I don't know. And then the next time it's measured, it has gone to 19. Okay, so it started at 16 and now it's at 19. And I want to know what the percentage change is from 16 to 19. Now, mathematically, if you want to know the change from 16, you would just simply do the new 19 minus the old 16. So 19 minus 16 is 3. And then you would divide by just 16. And that would be the percentage change from 16. But here's the thing about price elasticity of demand, is that we could be going, let's say, from 6 down to 5, or we could be going from 5 up to 6. And because price can go in two directions, we are not going to have a different price elasticity of demand whether we're increasing in price or decreasing in price. I mean, in real life, there might be a different price elasticity of demand, but this is a principles of microeconomics course, and so I don't want to confuse you with the direction of the change. And therefore, we are going to do the new minus the old divided by the average of the new and old. Well, what is the average of 16 and 19? Well, the average of any two numbers is always the halfway point. So for example, if we wanted to know the average between 20 and 22, halfway between 20 and 22 is 21. And the way we can calculate the halfway point is we add the two numbers together, so 21 plus 22, and then just divide by 2. So one of the numbers plus the other number, and then divide by 2. And 20 plus 22 is 42. Divide 42 by 2, and you get 21. Okay? And so the average of any two numbers, the average of the new and the old, is going to be the halfway between the two numbers. So halfway between 16 and 19, you could just add them together. So 19 plus 16 over 2 would be 35 over 2, which is 17.5. And 17.5 is indeed halfway between 16 and 19. So that's how we calculate a percentage change. So in this case, it would be 3, because 19 minus 16 is 3. 3 divided by 17.5. You could also divide the change, like the 3, divide the 3 by 2, that would give you 1.5, and then you can add it to the smaller number. 16 plus 1.5 is 17.5. But if we were to do this calculation here, what is 3 divided by 17.5? We get a calculator, and we go 3 divided by 17.5, which would give us 0.71428. 171428 or 29 if you round it. Now, in many of these, in my class, many of the answers, many of the final answers are going to be done to either 2 decimal places or 3 decimal places, one or the other. But here's the thing. When you're calculating the percentage change in quantity demanded, that's not your final answer. You're also going to calculate the percentage change in price. That's not the final answer. You have to divide those two numbers. And there's a rule in math that says that you never really round your answer until you get to the final answer. Okay, so don't go rounding all your calculations to 1 or 2 decimal places, because you could wind up with a wrong answer. Okay, so make sure that you are using as much of the number as possible. That's why I like to go out to like 6 decimal places. And I'll show you that again as we do some examples. So our calculation here is our price elasticity of demand is going to be the percentage change in quantity demanded over the percentage change in price. And a larger formula that could help you if you wanted to write this down would look like this. So we have a fraction. And to get the percentage change in quantity demanded, it would be the new quantity minus the old quantity. Or in price elasticity of demand, I like to do the larger quantity minus the smaller quantity, but it doesn't really matter. Let's go ahead and do the new quantity demanded minus the old quantity demanded divided by the average quantity demanded. So we would do that in the numerator, and that would give us the percentage change in quantity demanded. Then we would do the exact same thing in the denominator, only we would do it with price. We would do new price minus old price divided by average price. Okay? And so what I want to do over here is I want to identify the price elasticity of demand between 7 and 6, 6 and 5, 5 and 4, 4 and 3, and 3 and 2. Okay? So let's go ahead and do that. Let's go ahead and do that right now. So if we want to do the price, and I'm going to make a column here, price elasticity of demand. Now, something interesting is going to happen here. In this part of the table, instead of putting my answer right here or right here, I'm actually going to put it between the two, because the price elasticity of demand is happening between two prices and between two quantities. So I'm going to put the answer right here. So we're really only going to have 1, 2, 3, 4, 5 overall, because even though we have 6 entries in the table, we only have 5. 1, 2, 3, 4, and 5 spaces in between. Okay? All right, so when the price changes, let's say from 7 down to 6, quantity demanded goes from 20 up to 30. And so price elasticity of demand, we're going to have our new quantity. Our new quantity is 30 minus our old quantity, which was 20, divided by the average quantity. And the average between 30 and 20 is 25. So if you were to do 30, let me do it over here. If you were to do 30 plus 20 and divide that by 2, 30 plus 20 is 50, and 50 divided by 2 is 25. And that's why I'm putting a 25 down here in the denominator. Okay? So this is the percentage change in quantity demanded, and then we're going to do another fraction line here. And then for the denominator, we're going to have new price minus old price. The new price is 6, the old price is 7. So 6 minus 7 over the average price. Well, halfway between $6 and $7 is $6.50. So I'm just going to put 6.5. Now I'm going to need a calculator. And what I'm going to do here is I'm going to calculate separately. I'm going to calculate the percentage change in quantity demanded first, and that's going to be 30 minus 20, which is 10. So 10 divided by 25. And 10 divided by 25 is 0.4. So I'm just going to put 0.4. It's 0.4. Okay? And what that means is this, is that quantity, the percentage change in quantity is 40%. Okay? And now we're going to do the change in price. So 6 minus 7 is negative 1. And we're going to divide by 6.5. And that's negative 0.153846. 153846. Okay, so I got 0.4 divided by negative 0.153846. Okay? And so I went to 6 decimal places here, like I said before, because I don't want to do any careless rounding. I want to make sure that my final answer isn't too inaccurate. Okay, so now I'm going to do 0.4 divided by negative 0.153846, and I get negative 2.6 with 0, 0, 0, 0. So that's just negative 2.6. So I'm going to put negative 2.6. All right, now that's mostly our final answer, but it's not really our final answer, because now I need to talk about this negative symbol here. So, generally speaking, we do not indicate price elasticity of demand as a negative number. Because of the law of demand, price and quantity demanded move in different directions. You know, they have a negative relationship. Therefore, price elasticity of demand in almost every case, unless you're in an intermediate or an advanced microeconomics course, but we're here in a principles of microeconomics course, okay? Every product that we're going to deal with, the price and quantity are going to have a negative relationship, and therefore price elasticity of demand is always going to be negative. So what we do is we say, you know what? We know all of our answers are going to be negative, so we're just not going to include the negative. We're going to do the absolute value of negative 2.6. And therefore, the price elasticity of demand from between $6 and $7 is going to be 2.6. Okay? All right. Let's do now between 6 and 5. Let's do another calculation, and then what I'm going to do is I'm going to after we do one more together, because you may not feel fully comfortable yet, after that, when we go from 5 to 4 and 4 to 3 and 3 to 2, I'm going to sort of speed things up, okay? All right. So if we go from 6 to 5, quantity goes from 30 quantity demanded goes from 30 up to 40. And so we're going to do the new quantity minus the old quantity demanded, because we need the percentage change in quantity demanded. The new quantity demanded is 40 minus the old quantity demanded is 30. Actually, you know what? Let's do this. Just so that you can see this kind of an example, let's pretend that in this case the price went from $5 up to $6. Now this is the old and this is the new. And this is the old price and this is the new price. But what you're going to see is that it would give you the same answer anyways. So new quantity demanded minus old quantity demanded. So new quantity demanded is 30 minus old quantity demanded is 40 divided by the average between 30 and 40. And the average between 30 and 40 is 35. You would do 30 plus 40 divided by 2. All right, so that's the percentage change in quantity demanded. And now we're going to do the percentage change in price. The new price is $6 minus the old price was $5 divided by the average between 6 and 5 is 5.5. Okay? And so now let's grab a calculator. 30 minus 40, that's negative 10. Divided by 35, and that gives us negative 0.285. Remember, I'm going to go out a bunch of decimals here. 714, because I don't want to make a rounding error. And now here, 6 minus 5, that's positive 1, divided by 5.5, and that gives me 0.181818. 0.18, it's a repeating decimal, 1818, okay? Note now that the numerator is negative and the denominator is now positive. So that's a little different than the one we did just a few minutes ago, right? But it's still going to result in having a negative value for price elasticity of demand. So if we do this number right here, negative 0.285714, and divide that by 0.181818, we get negative 1.57, well, let's just say, let's go 571. Negative 1.571. But remember, with price elasticity of demand, we ignore the negative. We're going to get rid of the negative. So our price elasticity of demand is going to be 1.571. 1.571. Okay? All right. Here's what I think you should do right now. Pause this video, and then you do the elasticity between 5 and 4, 4 and 3, and 3 and 2. And then I'll work through them real quick, and then you can check your answers. And so what you should have come up with are these numbers right here for price elasticity of demand. You should have come up with 1 between $4 and $5. You should have come up with 0.64, or it could have been 0.646 maybe, or sorry, 636 I think maybe. I did 2 decimals here. I just want to show you some variety that it can be. You can round to 3 digits, you can round to 2 digits. That's fine. And well, depending on what I ask you to do in the questions. But this one right here is 0.38. Okay, and so hopefully you got those calculations correct. All right, so now I want to explain how we characterize these different numbers. We have 3 different words that we use to describe the elasticity of demand, the price elasticity of demand of a product, depending on its price. The first thing I want you to notice is that, remember we said that this has a constant slope? And so it has a constant slope in terms of the relationship between price and quantity demanded. But look, the price elasticity of demand is actually different. As the price goes down, our price elasticity of demand is decreasing. Okay? Now, here's the deal. When the price elasticity of demand is equal to 1, we call that unitary elastic. So, this particular product, whatever it is, between $4 and $5, this product is unitary elastic. And that means something very specific in the world of economics and also finance. Well, I don't know how far it goes into finance, but it's related to the finances of the business. When the price elasticity of demand that is calculated is larger than 1. Okay, so unitary elastic is when price elasticity of demand is equal to 1. When price elasticity of demand is greater than 1, we call that elastic. That is elastic demand. And when the price elasticity of demand is smaller than 1, price elasticity of demand is less than 1, we call that inelastic. Inelastic. Okay? And so, between a price of $2 and $4, this product has inelastic demand. Between $4 and $5, it is unitary elastic, and at a price larger than $5, the demand for this product is elastic. And what I want to do now is I want to explain what happens in a business, how this information can be useful to decision makers in a business. So whenever I see, I'm going to erase this right here. Whenever I see price and quantity, and you've seen me do this before, whenever I see price and quantity together, that makes me want to calculate total revenue. And the reason I want to calculate total revenue when I see price and quantities near each other is because the formula for total revenue is equal to price times quantity. You already know that. And so what I'm going to do is I'm going to go ahead and put in a column here. In fact, you should go ahead and put that in too. I'm going to put total revenue here. What I want you to do right now is I want you to pause the video and I want you to calculate the total revenue at each one of these prices. So calculate 6 different total revenues. Go. All right, so hopefully you did price times quantity. So price of 7 gives us a quantity of 20, and price times quantity, so 7 times 20 is $140. So if this was the market that was being faced by this product, then this company would earn $140 in total revenue. Now, if we go to $6, $6 times 30, that's $180. 180. $5 times 40 is $200. And then $4 times 50 units, that also is $200. $3 times 60 units, that's $180. And then $2 times 70 units, that is $140. And so look what's happening here. I think you could probably see something interesting here. And what I want to do now is I want to relate this idea of total revenue to the elasticity of demand number. And so what I would do if you take sub notes is I would now note what we're about to say as the relationship between price elasticity of demand and total revenue. So there's an interesting relationship between price elasticity of demand and total revenue. And here's what I want you to notice. First of all, total revenue is highest when we're here at a price elasticity of demand of 1, so unitary elasticity. So the first thing I want you to write down is this, is that total revenue is maximized. A company will experience its highest total revenue when the demand for that product, when they set a price for that product where the demand has unitary elasticity. So total revenue is maximized at the price, or at a price, let's say at a price, where price elasticity of demand is unitary. Okay? Now, I do want to comment on that before we move on with the other 2 points that I want to make, and that is this, is You may think then that the ideal thing for a company to do is set its price so that price elasticity of demand is unitary. But this is a bad idea. Well, not always a bad idea, but this is a bad idea. I want to remind you something. Here we are in microeconomics. We're talking about consumers, and we're talking about firms, right? Remember that consumers are trying to maximize utility, right? What are firms trying to maximize? Are they trying to maximize total revenue? The answer is no. If you think back to what we've been learning so far, we've said repeatedly, firms are trying to maximize their profit, not their revenue. And therefore, I actually don't recommend that a company sets their price to where they have unitary price elasticity of demand. I want to remind you, you've learned in a previous lesson that to maximize profit, you need to choose a quantity when you have a price where marginal revenue is equal to marginal cost. This is still going to rule over the quantity decisions of a business. But you want to be careful because there are a lot of businesses out there that get tempted to focus on maximizing their total revenue. And that is not always the best thing to do. In fact, it's usually not the best thing to do in business. Okay? All right, but it is important to understand that total revenue is maximized at a price where price elasticity of demand is unitary. But now look what happens. Let's say we're here in the elastic region here, right? What happens, you would think that a company, if they had the chance to raise their price, they would raise their price for sure. They say, oh, I can increase my price, I'd make a lot more money. If I'm selling 100 units and I increase my price by $1, I'll make another $100. Hang on a second. Remember the law of demand. The law of demand says that when you raise your price, quantity demanded will decrease. So, higher price but lower quantity. And when you're calculating total revenue, because total revenue is equal to price times quantity, if this number goes up, this number is going down. And that will not guarantee you that this number will go up. Because if this number goes down far enough, then this number will not go up. It'll actually go down. And remember, elastic demand means that when the price changes, you're going to have a larger percentage change in quantity demanded. And so when this price goes up, this quantity is going to go down by a lot. And it's probably going to go down by so much that your total revenue is actually going to go down. So you can see that right here in the graph. That when we're in the elastic range, when our elasticity is larger than 1, an increase in price actually moves total revenue down. We're going from 200 down to 180. And when the price goes from $6 up to $7, total revenue goes from 180 down to 140. And so the second thing that I want you to write down goes like this, is total revenue will decrease when price is increased if price elasticity of demand is elastic. And now hopefully you can see where I'm going with the third point. If we go down here now to the inelastic region where the elasticity is less than 1, you can see down here that if we have an increase in price, so if we increase from $2 to $3, our total revenue goes from 140 to 180. That's good for us, right? An increase in price that results in an increase in total revenue. And so, should we increase the price? Maybe. Again, it really, first of all, you don't always have control over your price. It depends on what kind of market you're in, and we'll get into that in Unit 3. But for right now, it seems like it makes sense that if increasing the price is going to increase your total revenue, then why not increase the price? Okay? And if we go from $3 to $4, then our total revenue goes from $180 to $200. And that's when we reach unitary elasticity, and any increase in price at this point is going to decrease our total revenue. I do want to say this though. Increasing your price when the demand is elastic, even though it may reduce your total revenue, it is possible, given your cost structure, that it might actually result in more profit. So really you have to look at the whole picture, not just the elasticity and not just the total revenue. All right, so our third statement here and final statement on total revenue is that total revenue will increase. Total revenue will increase when price is increased if price elasticity of demand is inelastic. Okay? So make sure that you have these comments in your note or in your notes, because I will ask you questions where basically I say, hey, here's the information. I'll give you a couple prices. I'll give you a couple quantities demanded. You're going to have to calculate the price elasticity of demand. And then I will then ask you to conclude, therefore, if there's an increase or a decrease in price, what will happen to total revenue? You have to be able to answer that, okay? All right, so I've created this sort of effect graphic here, a diagram, that you can use to try and understand how price elasticity of demand affects total revenue. So we know, depending on the calculation, we would have to do the calculation. We do percentage change in quantity demanded divided by percentage change in price. And once we calculate that, if that number is equal to 1, then price elasticity of demand is unitary. If that number is less than 1, then the price elasticity of demand is inelastic. And if that number is greater than 1, then the price elasticity of demand is elastic. And once we know the elasticity of demand, we can then draw conclusions about how a price change will affect. So I'm going to put right here price change, okay, and that's going to be in this little region right here. I'll use blue. How is a price change going to affect total revenue? Okay, and so here's what we have. When price elasticity of demand is unitary, see, I put this kind of dashed arrow because honestly, if price elasticity of demand is unitary, then there would be no relationship between a price change and total revenue because well, we saw previously why. Okay, there'd be no change in total revenue. But when demand is elastic, an increase in price will result in a decrease in total revenue. So that would indicate a negative relationship. And if the demand is inelastic, then a price change is going to result in a positive change. Meaning, if the elasticity is inelastic, if the price goes up, total revenue goes up. If the price goes down, total revenue will go down. A negative relationship means that the opposite will occur. If the price goes up, total revenue will go down. If the price goes down, total revenue will go up. Okay? And what I now want to do on this diagram is I want to put over here four things that actually affect the price elasticity of demand of a product. The determinants of price elasticity of demand. So I'm going to write here determinants of price elasticity of demand. Okay? Now the first one, consider this. Would you say that, we already talked about gasoline, right? Now one of the reasons why gasoline the demand for gasoline is very inelastic is because it is seen as a necessity. But there are things in this world that are not necessities. They would be the opposite of a necessity, might be what we would call a luxury. And so what we're going to say here is, we're going to say necessity versus luxury. All right? And so typically, if the product is seen as a luxury, then what we typically have is more elastic, or a higher elasticity. And if the product is seen as a necessity, people need it, like bread, milk, gasoline, housing, that sort of thing, then the demand is typically less elastic. Actually, let's write it like this. Here's what I'm going to write. For a luxury, we're going to put an arrow up. We're going to say higher price elasticity of demand, and necessity results in a lower price elasticity of demand. Okay? A second possibility is this, let's say the price goes up on something that you purchase, like let's say that you buy Pepsi, okay, you're a drinker of Pepsi, and the price of Pepsi goes up. Well, you could just go buy Sprite, or you could buy a bottle of water instead of Pepsi. So if you're mad that the price of Pepsi went up, you could just go buy a different drink, right? And so remember that we call those substitutes in economics. Something that meets the same need for utility in a different product, though, we call that other product a substitute. Now, gasoline, one of the reasons gasoline has such inelastic demand is because there is no substitute for gasoline. You can't pull your car up, you can't put diesel in your car if it's a gasoline engine. You can't put, you can't put much of anything. You can't put anything except gasoline. The only choices you have are whether you're buying, 89 octane or 87 octane or ethanol free or whatever. But it's still all gasoline. And so the question of whether there are substitutes. Are there substitutes for the product that you're dealing with? And the options are there could be fewer substitutes, or there could be many substitutes for the product that you're producing and selling or that you're dealing with. Okay? When there are fewer substitutes, then price elasticity of demand is going to be lower. But when there are many substitutes, if there are lots of things that you can substitute, when the price goes up, you'll just go buy one of those other things. Quantity demanded will change a lot. There's higher price elasticity of demand. Okay? All right. The next one we're going to talk about is what's called percentage of budget. Percentage of budget. Okay, now, when I say percentage of budget, we could say that something you're buying is a smaller, let's say smaller, yeah, is a smaller percentage of your budget, smaller, or we could say that it is a larger percentage of your budget. Example, a soda is probably a very small percentage of your budget. If your income is like, $2,000 a month, you can probably, a $2 soda is, less than 0.1% of your budget, okay? But your rent, if you're paying like $700 a month in rent, that's like 35% of your budget. That's a lot of your budget. So some of the things that you spend your money on take up a smaller percentage of your budget. Other things that you spend your money on make up a much larger percentage of your budget. And the idea is this, is that the larger the percentage of your budget, the more elastic the demand is. Because you're already paying a lot for this thing. If the price goes up, you may think, I can't even buy it anymore because it already takes up such a percentage of my budget. I can't take away 14 different things just to handle an increase in the budget here. And this is one of the reasons why a lot of luxuries, a lot of times, you have to be very careful about having too high of a price or people may just decide not to buy it. Some luxuries like, Netflix. Netflix is so much cheaper than cable. I mean, I don't even have cable anymore. Well, I don't have Netflix anymore either. But cable started getting so high in price, a lot of people started dropping cable. They were like, I'll just watch the internet. So anyway, when a product takes up a smaller proportion of your budget, the demand is going to be less elastic. But when that product takes up a much larger percentage of people's budgets, then the elasticity is going to be much higher. Okay? And now, there's only one more thing that we're going to talk about, and it's called response time. Response time. When I say response time, what I mean is this. When the price changes, how much time do you have to respond before you change your mind about making a purchase? And the idea goes like this, is you might have very little time to respond. Let's say you're about to go make a purchase tomorrow and overnight the price went up. But you're already committed. You've already made all the plans that you're going to make that purchase. Well, you're going to make the purchase. You're just going to pay extra money because maybe you need it, right? Let's say you're buying something, you're manufacturing something, you're buying a part. Let's say you're buying tires. You've already made the commitment about how many tires you need. You haven't made the purchase yet, but the next day you go to make the purchase and the price increased. Now you can think to yourself, oh man, well maybe it's not necessary, or hey, there's other substitutes. But you've already made your plan. You're ready to move. You don't really have a lot of time to make a decision because they increased their price. And therefore, the elasticity is going to be lower. It's going to be inelastic. Price elasticity of demand will be lower when you have very little response time. But if you have a lot of time to plan, if the price goes up and you have a lot of time to make plans, you can just reform your plans. And so you can, so when there's a lot of time to respond to a price change, then elasticity of demand, price elasticity of demand is going to be much higher. Okay? All right. Well, that's it for this lesson. That's price elasticity of demand. You need to understand the determinants of price elasticity of demand. You need to know how to calculate price elasticity of demand. You need to be able to characterize a product as having demand that is elastic, unitary, or inelastic. And then lastly, you have to be able to identify how a price change is going to affect total revenue based on the elasticity of demand for a product. Okay?